This is an Junior Science Olympiad STEM communication, and we are focusing on the aspect of physics today. Well, this is an emergency expository, so please you have to bear with me if you see me jumping from one area or the other, because what you need as a candidate preparing for Junior Science Olympiad examination is to be well exposed in diversity. As a matter of fact, Olympiad is an international program and it is highly diversified. Then based on the past question that I have seen, that it requires proactiveness. So you may see me moving from one aspect, content, to the other. Number one, why water wet glass? Water, why it wet glass? I'm sure you know that water, the chemical formula for water is H2O. Why does it wet glass? If you put water in a glass content, okay, why does it wet glass? Now, it wet glass when adhesive force, the adhesive force or bonding, let me use bonding, is greater than the cohesive bonding. Now, the question is, what is the meaning of adhesive bonding and cohesive bonding? Now, water has molecules, and the molecules of water in thousands are always attracting one another. So the force that exists between molecules of water is called cohesive force within the water itself. Now, adhesive force, you can see that this water is poured inside maybe a container made of glass material. Even the materials, atoms, has a force also. It is made up of atoms. Now, the molecules of water and the glass atoms are interacting. The force between a particular content, molecular materials, and another one is called adhesive force. And so when you pour water inside a glass container like this, okay, there is an interaction, a intermolecular interaction between the molecules of the water and the molecules of the glass. Now, when that is bigger than, and that is called adhesive bonding or adhesive force. Once it is more than that of the cohesive force, the interactive attraction between molecules of a particular liquid, then once it is greater in this content, then water wets glass. Number two, why water do not wet itself? Yes, that means water is not poured into any container. Why is that? It does not wet itself. It does not wet itself because it is it only exists by cohesive what? Bonding. Okay? Wetness only occurs from the interaction between a liquid and a solid substance. This glass is a solid substance. So you experience wetting because the adhesive force or adhesive bonding is more than cohesive bonding. But water does not wet itself because it only exists by cohesive what? Bonding. When it is not interacting with the particulates of a solid substance. Another one, why water is sticky? Why is water stick to the wall of any surface? When you pour water, why is that you see some appearance of water on the surface of that container? Okay? The reason is because water has two atoms of hydrogen, okay? And one atom of what? Bonded. These two atoms of hydrogen is bonded with what? Into. Okay? Now, another one is why water is a bad thermometric substance. Yes. Thermometric substance. Now, let me explain what is meant by thermometric what? Substance. We all know what is called thermometer, right? Thermometer is an instrument for measuring what? The degree of hotness or coldness of what? And all. Yes. Meaning thermometer is used to measure temperature. Simple. Now, these thermometers are made with materials, mostly liquid or gaseous, that respond to change what? Temperature. And the common liquid are alcohol and what? Mercury. Why is that water? Look here, why is water not used as a thermometric substance? Meaning as a substance that responds to change the what? If if the thermometric substance does not respond to change the temperature, you cannot measure the temperature of a what? Of an object or a body. Now, water in this case is a badge of a poor thermometric what? For two reasons. Number one, it has high freezing point and low boiling point. The question is, what is the freezing point of ice? 0 degree what? Celsius or 273 degree Kelvin or 212 degree Fahrenheit. Take note of that. All these are questions you can come across. The freezing point. Oh, sorry. I'm sorry. This one is 32 degree what? Fahrenheit. That is the freezing point of water. Okay, in degree, in Kelvin, in Fahrenheit. Are you following?
Yes.
It means that then what is the boiling point of water? 100 degree what?
Celsius.
Or 373 degree Kelvin. Or 212 degree what?
Fahrenheit.
Take note. We are going to go into this, how to convert this. This is okay?
Yes.
So we say that water with 0 degree Celsius has high water.
Freezing point.
It means that any temperature below 0, like maybe minus 20 degree what?
Celsius.
You cannot use water as a thermometric source. It cannot measure it. Then we have the boiling point of water is 100. It means any substance that has a higher temperature, like maybe 120 degree what?
Celsius.
So it has a high freezing point and a low boiling point. That is one reason. Second reason, take note, look here, is that it has low heat conductivity. What did I say?
Low heat conductivity.
It has low what?
Heat conductivity.
Meaning it cannot expand proportionate to temperature change. It cannot respond. Okay? Water does not respond to temperature what? Change. And for a substance to be a good thermometric what? Substance, it should be able to respond proportionately with temperature what? Change. So water does not have to, it has low heat what? I believe I'll be able to make myself clear there. Now let's now look at why is mercury. The symbol for mercury is capital letter H and small letter G. That's the symbol for mercury. Okay? Why is mercury better than what? Water as a thermometric what?
Substance.
Why is mercury better than water? Look at it. Listen. It has a freezing point that is less than minus 100 degrees Celsius. Hello? That means something below 0. You can use a thermometer that has mercury as a thermometric substance to measure. Is that clear?
Yes.
That means that's a low what? Low freezing point. Remember, water has high what? It's minus 0, minus 100 degrees, not lower than 0.
Yes.
It is far lower. So, do you understand?
Yes.
So, because of that, it is better, okay? It can measure, so it means that a thermometer that has mercury can measure very low temperature. It can measure very low temperature. Are you following? It can measure very low. Please take note of all this stuff. Now, I want to go to another aspect. That is enough of that. Take note of all those information. Don't forget cohesive bonding of force and what? Adhesive bonding of force. Cohesive bonding is within the molecules of a liquid substance. Those molecules, they are fighting. Let me put it that way in the layman language. They are attracting one another. Okay. Now, adhesive what? Bonding exists between the molecule of liquid and the molecule of a solid what? So, like glass, like plastic, and whatever. Is that clear? So the interaction between the two give rise to what? Adhesive force. And don't forget, we said that water, wet glass, when the adhesive force is greater than cohesive force. Is that clear?
Yes.
Now, we also said that water does not wet itself, because wetness only happens when there is an interaction between adhesive bonding and what? Cohesive bonding. Thank you very much. Now, another aspect that I saw is measuring instruments. Let's quickly look at that. I saw that in the question, and then we need to work around that. Okay? Now, spectrometer, spectrometer, photometer, ventrimeter. Now, this is the one I saw in the question. This one, ventrimeter. And that is the one that necessitates me going to this, so that we can look at other aspects of the instrument you are likely to come across. Is that clear? Okay, let me start with this before I start mentioning others. Spectrometer. It is used to produce light. To produce light of any wavelength. Okay?
Yes.
Spectrometer. Now, when light is produced, we have photo what?
Photometer.
This one is used to measure light intensity. How intense? To measure what? Light what?
Intensity.
To measure light intensity. Take note of that. Now, ventrimeter. This one is used to measure the speed or velocity of flow in fluid. In this case, fluid can be water, it can be blood that flow in the arteries. Okay?
Yes.
In the arteries, in our body circulatory arteries. Okay? So, what is ventrimeter used for? To measure what?
Speed or velocity of flow in.
Or you can say to determine flow rate. What do I call it?
Flow rate.
Of fluid. Take note of that. To determine the flow rate of what? Of fluid. Take note of that. Okay? So it means that in water engineering, engineers make use of what? Ventrimeter to measure the flow of water, the speed of flow of water in pipes. As the pipe that connects water to your houses, okay? When you want to know the rate at which this moving, they connect to what? Ventrimeter. Okay? Then the medical doctors, in the medical lines, they also want to see the rate of pumping or flow of your blood in your heart and arteries. So that's when they do the connection medically. Then they can use ventrimeter to do that. So take note of that as we move on. Now, we have others, anemometer. Anemometer. We have barometer. We have caliper. We have manometer. Don't forget there is barometer, there is manometer. I've told about photometer already. Okay. Then we have pherometer. Now take note of these. They can ask you this. Pherometer. Okay. Okay. Before I mention other ones, then we have odometer. Please. Then we have mass spectrometer. Different from spectrometer, ordinary spectrometer. This one is mass spectrometer. Is there another one? Okay, there are other ones that I'm going to discuss briefly, but before then, let's quickly look at this one. Now let's start with mass spectrometer. This one is used to measure the mass of an ion or to determine the chemical weight of a substance. Spectrometer. Anemometer is used to measure wind speed. Anemometer. Okay?
Yes.
Okay, then we have caliper. This caliper is used to measure distance or length. Okay? Barometer, atmospheric pressure. Take note of that. Atmospheric what?
Pressure.
Atmospheric pressure. We used to measure atmospheric pressure. Okay? Now, this one, manometer. This one is used to measure gas pressure. Barometer, atmospheric what? Pressure. Now look at this. I'm still going to discuss this one, but it's very special, so I want to mention it here. Under heat and energy, by the time I'm taking that, under this Olympiad stuff, I'm going to talk. But for now, pherometer is a thermometer. It's a special thermometer used to measure very high temperature. Hey, take note of that. Pherometer is used to measure what? Very high what?
Temperature.
Temperature. like furnace, bakery, or where they assemble automobiles. There's a serious heat due to welding, joining of metals together.
Yeah.
Where they join metal welding, you need a very high thermometer that can measure very high temperature. So phyrometer come into play. Now, odometer, look at this one, odometer. This one is used to measure the distance traveled by vehicular wheel. The wheel of a vehicle as it is moving. This, okay? The distance it's able to cover, we use odometer to do what? To measure them. Now, still on measuring instruments, please direct the camera here. Still on measuring instrument, there are other ones I need to talk about. Ohm meter, voltmeter, wattmeter, ammeter, galvanometer, galvanometer. Now, this one, ohm meter is used to measure material resistance, the resistance of material. Voltmeter is used to measure voltage, as the name implies. That voltage can be potential difference or electromotive force, EMF. Hey, potential difference, electromotive force, they mean voltage. We use voltmeter to measure that. Then wattmeter is used to measure the power or energy rate. Power or energy rate in an electrical circuit. Power or energy rate. Don't forget that power is energy over time, and that's why we call it energy rate. Then ammeter is used to measure electric current. What do I call it? Electric amount of electric current. Now, galvanometer. This one is also used to measure electric current, but small or trace flow of electric current. Small. This one is used to measure electric current that's relatively large. Galvanometer is a small, okay? It's used to measure small or trace flow of what? Electric what? Current. As a matter of fact, it is a detector. It is very sensitive to detect flow of what? Current, electric current. To detect traces or small flow of electric what? Current. We are making progress. Let's move inside the past question proper. Those ones are additional information that I thought we should be okay. Now the next one, I think let me explain this. We are done with measuring instruments. So many information for you to be an Olympiad student, you need to be well informed. So this is an emergency tutorial class designed for candidates preparing for 2023 Olympiad first round. Then when you cross over to first round, they will know what to do thereafter, okay? What is the subsequent round? Now, there's a question I need to read out here, fast. I'll move on. The internal friction in a fluid. When we say fluid, it means matter that flow. Substances that flow. And a good example is water or liquid. Liquid substance, flow. Liquid petrol, kerosene, they flow. So the internal friction in fluid is called viscosity. Take note of that. The friction that exists within liquid or solid that flow is viscosity. But the friction that exists between solid material, this solid material is that one is called friction. Okay? Take note of that. Now, another question. I need to be deliberate here. Look at this question. It says soap film, okay, exhibit brilliant colors in sunlight due to soap film exhibit brilliant colors in sunlight due to interference is the answer. Interference. Okay? In bright light, they exhibit brilliant colors in sunlight. The reason is because there is interference that is causing that to be. That interference can be constructive interference, or it can be disruptive interference. Okay, so interference causes that to happen. Now another question: a pencil dipped partially in water appear bent because of, you see, when you have a water substance like this, a container having water, and there is a pencil. This one is air, open space. This is water. Now this pencil, this one is water, right? Now the rays of light that surround this pencil in the open, in the air, travel faster compared to when it want to enter water. So as soon as it enter water, okay, this will diffract. It will diffract because there is a slowing down of the rays of light moving inside what? Water. So what causes that? So it will now appear as if this pencil inside water is appearing bent. Is that clear? As if it's bent. The reason is because there is what? Refraction. Sorry. Because of refraction. Take note of that. That happened because of what? Refraction. Now, a substance that can flow is that's a fluid. I've said it. They said solid, gas, liquid, fluid, none of the above. A substance that can flow is a what?
Liquid.
Now, apart from liquid, in agricultural engineering, which is one of the courses I study at my master level, series or grains, solid agricultural particles also flow. That's why when you are measuring a module of rice, you prepare it, as you pour it, what happens? It's flowing. As you pour it, so grains like beans, rice, millet, and so on and so forth, also what? Flow. So some solid substance that are of small sizes also flow when they are being poured. Is that clear? But naturally, it is liquid that flow. Am I communicating? Okay. Now, look at this next question. This is interesting. This question says that why is it that birds, which other one, planes and boats are streamlined? That's an intelligent question. Why is it that birds, planes, boats are what?
Streamlined.
Now, bird is living things. Planes and boats are what? Okay, when you say planes, that means aeroplane, jet planes, and all those things. Why are they streamlined? Streamlined means, why do they have body shape like this? Compare this to this. Are they the same? No. A, B. This is streamlined. That means at a particular side of their structure, it is what? Narrow. It narrows. That is streamlined. Okay? The reason is that if you look at these objects, some of them fly in the what? Air. Some of them fly in the what? Water. Now, they are both called air resistance and water what? For objects that flow in them, in this medium. Is that clear? So they are made streamlined for what? So that they can drag or water friction can be minimized, or air friction. Because you are dragging something in air, there is effect of air on it. And for the object to be able to move through, okay, that object must be designed in such a way that it will be able to what? Move through those impediments or obstructions. So the answer is that to be able to reduce fluid friction in case of water body and drag friction in case of solid planes, boats, and water view. So take note of that. That's a very good question. Now this will come back. The camera is complaining of space, so we'll come back for another part, continuation of this. as part. So this is part 2 of our Olympiad class. Is that also?
Yes.
Okay, thank you very much. See you next.
Shopping at the baby girl lifestyle. Fendi go dey tire you, baby. You know say me go love you scatter. Give me a shotty, yo. Make I know the level on me. Tell me the truth, matter me. Or they push your P, cause I like you a lot. Fine girl, say she